Hi, everyone. Welcome to Potentials. This is Lija, and our special guest tonight is Chris Beskar. And of course, we have Ed Kabursky returning as well. And thank you so much, Chris, for coming back on the show. I really appreciate it.
Oh, you're very welcome. It's my pleasure.
Yes. So we were just talking right before we started about the hangar that's behind you. And I was curious how old that hangar is.
Well, that's a good question. We're curious how old the hangar is too. Um, the whole site is fairly old. We're at the Niagara Falls International Airport. The hangar itself is about 42,000 square feet.
Wow.
It was built by the military in the 1950s. It started out as a Navy facility. And
Oh, wow.
we were just commenting on how the facility had 12 spots for fighter aircraft, and it had Vought Cutlass aircraft in it initially, which is kind of a rare airplane. It wasn't a very popular fighter. Vought made a lot of great airplanes like the Corsair, Corsair 1 and Corsair 2 and all that, but the Cutlass
Yeah.
was not very successful. Uh,
Mm,
and so the Navy operated the facility. They had missiles, they had alert. The facility itself, the hangar, has magazines for missiles and things like that. We have gantries and
Wow.
trains, and it's pretty cool in that sense. So it was built and added onto from basically the 50s through the 90s, I believe. And we have a total of 7 buildings there today, maybe 8. I think there were 10 on the property. We tore 2 down that were condemned. And the rest of the facilities here are in pretty good working order, although they do need some remodeling. We're doing some major infrastructure improvements. And it totals roughly about 170,000 square feet over all of the different buildings.
Oh,
wow.
wow.
So it's
It's
big.
amazing.
We have our own substation, which goes up to 3 megawatts as is.
Wow.
That's something we're actually updating because this is the funny thing about aging it. When we did the analysis and aging on the substation, there were components from the 1920s in the substation.
That's what I was
No way.
thinking.
So
Holy cow.
Yes, yes. I was wondering about that because it
yeah,
looks like it could hold an airship,
yeah.
like,
So it's pretty big. It's one of the bigger hangars. It's certainly one of the big single standalone hangars. And what was cool about it and why we bought it is most hangars don't have large offices. And
mm,
we have an office segment on the north and on the south side. And the office totals, gosh, I have the numbers, but it's like another 50,000 square feet. And so
wow.
Wow.
it's just huge, multi-floor offices. And
Mhm.
so one's a 3-story, one's a 2-story. And so it's pretty sizable. And other facilities that go around the rest of the property. So the whole property is about 20 acres of tarmac, lots of concrete. We can put a 737 in the hangar if we wanted to, or a C-130. Big,
Mm,
Wow.
it's pretty tall, and
yeah.
Yeah.
it's kind of our prototyping center, our skunk works. What you see in the background is the still shot. We have other things in it at the moment, so I'm not hovering in front of the hangar, but it's pretty cool.
That is cool. Thank you. Thanks for sharing that information. So Ed, you had a few questions. I just jumped in.
Yeah. There's a big long runway too, isn't it? A 10,000 foot runway that was an alternate
It,
for the space shuttle.
it is. It's almost 11,000 feet long. There's a
Wow.
couple of runways here, but the long primary runways over 10,000 feet. It is a secondary for the space shuttle. So it's a great facility, and we're right on the, I guess you'd say, the western southern side of that, and have our ramp goes right up to the taxiway and to the runway. So
Oh, that's awesome. One of the things that I really like about this is Nikola Tesla started our modern world in Niagara Falls with, the dam, the generators and the
right,
power. And here you guys are in exactly the same place, about to start a whole other revolution in flying, but also in energy production as well at some point as well too, right? So it's very, very cool. And I also know that you like your Russian aluminum. What is it, Scandia aluminum, I think
yes,
it's
yes,
called.
it's candium
Yeah,
aluminum, yeah.
yeah, yeah. And are there any other facilities that you guys have, or is this just the main one?
This is the main one, and right now we're doing a site selection process for the larger plant because this is not a factory really. We
Yeah.
have space to manufacture prototypes and do low rate production. That would mean maybe like 40 airplanes a year or something like that. But as
Okay.
far as mass production, it's not an assembly line. We
Yeah.
do have enough space on the whole site that we could build another larger hangar, and that would be for something like a 747 size airplane. And
Okay.
there was and this goes back to the history, there used to be a very large wooden hangar on the site, a secondary hangar, and apparently that burned down sometime in the past.
Oh,
But there's
Oh,
still, the footings are still there, so you could theoretically use the footings. But
wow.
um,
but
was it the Bell Aerospace facility there, originally?
well, the Bell Aerospace facility is down the street, and
Okay.
that's a neat facility. They have about 90 some acres. It's now called the Wheatfield Business Park, and uh,
Oh,
and so that's
okay.
about a 1.7 million square foot facility. And
Wow.
Wow.
so that's a site that we've we can't really talk about it because we did enter into an agreement about that some time ago, but it's a potential
Uh-huh.
site,
Um,
and
yeah,
we're
actually, I had a conversation with Dr. Depak about what you're talking about, as a matter of fact. So yeah, I won't say any more.
yeah,
Yeah.
yeah, that's under an agreement, so we shouldn't talk about it. But I can say that one of the challenges with that facility is it was built for World War II fighter aircraft production, like the P-39 Airacobra. And the challenge with that is the ceiling height is 30 feet. So,
Oh,
the ceiling of our hangar is taller than that. So if we want to build an airplane that's taller than 30 feet, and some of our designs are, we would have to build a different facility.
right,
And so
right.
we are looking at sites and locations throughout the country, including, there's a list: Texas, Colorado, California, Arizona, New Mexico,
Wow.
different places around the country. But
Yeah.
we're getting prototyping done here, and then we'll take our next steps over the next year or two.
Okay, in the next year or two, that's cool. Because I was going to say, yeah, eventually all of those places that you mentioned could be factories for Stavatti to build hover cars and planes, right?
That's right.
Yeah. Because I took engineering, and when I took engineering, we did a lot of production line stuff, manufacturing techniques, setting up production lines, and all that stuff. So when you talked about doing 300,000 hover cars a year, I was like, wow, I need to ask more questions about this specifically. Are they going to be 3D printed, or how are they going to be manufactured?
Well, some of the parts will be 3D printed. There will be, 3D printing is becoming a lot more useful these days and is being used in a lot of aerospace parts. So
Yeah,
definitely there will be 3D printed components. A lot of parts will be hydropressed and more like stamped out the way you make automobiles.
yeah,
And part of the challenge, composites have become so popular, but laying up composites is a time, it takes a lot of time, and it's a
yeah,
labor intensive process. And the challenge with that is it's very hard to mass produce composite parts. Uh,
right,
Possible to do it, but oftentimes it's very expensive, and you don't have the longevity necessarily that you may have with a metal part. And
Mm-hmm.
so
right.
it's a question. So it's actually cheaper for us to stamp out titanium than it is to make graphite composite. So
No way,
yeah,
really?
it,
Wow.
it's strange how that works out. So
Um,
Wow.
yeah, and you said hydroform. I used to race two strokes. I've ridden all the crazy bikes, but I had a road race bike, and the pipes were hydroformed,
yeah.
like the expansion chambers, and yeah, they were beautiful, beautifully done, and they work very well. So you would stamp out titanium. That's amazing. That's really cool to hear. And talking about that, today I went on your site on X,
Mhm.
and I saw something the other day about a new material that you've got set up for DARPA. But today I saw the titanium diboride,
Yes.
and how that is going to be used in the SM-39. Can you explain a little bit more about that? Because that's really fascinating.
Sure. Well, that's a metal ceramic. It incorporates elements of boron, and that's a high temperature material. It's a very high temperature titanium, and the density of that material is about the same as titanium. As a matter of
Oh,
fact,
wow.
it's lower. So it has extraordinary mechanical properties. It doesn't it has a very low thermal coefficient of thermal expansion, so it doesn't
Okay.
expand very much at high temperatures.
Yeah.
And it's basically a high temperature, very stiff and resilient material. And as a consequence, you can have engines made out of this. You can have engine components. You can have airframes. And so if you're building an airplane for high speed out of a metal, that's really a great material to use. And so we've been looking at that for about a decade now and pioneering
Okay.
a lot of the manufacturing techniques to make that in large quantities. And
Right.
so that's a big thing. And we had a meeting with DARPA back in December, and this particular RFI, actually two RFIs we responded to in April this month, really were oriented towards components that go into the Razor and as a high Mach airplane.
Yep. Yeah, exact. So what kind of temperature would you see on the Razor when it's at Mach 4 on the skin of that material?
Well, it really depends on your altitude and
Right.
the density, but you're looking at around the 2000 degree Fahrenheit range at times. You know,
Wow.
it is quite hot. The main concern is the engine components. And so
Oh,
that's where the heat is really the most critical aspect, not so much the skin, because you have the leading edge skin temperatures, and then further down the skin of the airplane, the temperatures do differentiate.
yeah.
But the power plant, the intake, the combustion chamber, all of that, and that's really where we're getting our thermodynamic efficiencies. And so there's a lot of different tricks we're doing to have the air come in, compress it, have it come out, reduce signature, reduce exhaust gas emissions, reduce NOx, all of
Yeah.
that. And
Yeah.
instead of, it's kind of funny when you get into engines, generally speaking, the higher the temperature differential, the more efficient.
Mhm.
And
Right.
so if you can get an engine to operate at a very high temperature, even upwards of, plasma combustion type temperatures, you'll get
Wow.
very high efficiencies. But often the problem is you increase your NOx or something like that. And so balancing out how you do that is important. So that's kind of what that whole program is about.
So what kind of temperatures were you talking about then in the engine you'd see there? Just
The
out of
engine, yeah,
curiosity.
that's really up to about 5,000 degrees in parts.
Wow. Was the SR-71 engine all built out of titanium, or because I know the whole other
Well,
part of the plane was?
it had a lot of super alloys at the time. I think it had quite a bit of Inconel in it. And
Okay,
so
yeah,
it
yeah,
was a high temperature engine.
yeah. It's got a lot of nickel in it, doesn't it? That,
Yeah,
yeah, yeah,
lots of nickel super alloys at the time. So
yeah,
that's
yeah. Very,
that was
very cool.
a really neat engine. You learned a lot from it.
That's a neat plane altogether. And I love the story about how they bought titanium from the Russians
Yeah.
to build a spy plane to spy on the Russians with it,
Right.
right?
Yeah, that's pretty wild. Yeah, they sure
Yeah,
did.
yeah.
And
Um, we have some pictures we'd like to share and bring up
Okay.
on the screen and maybe ask
okay,
a few questions about.
sure.
All right. I
You want to
didn't
do
want
that
to
one first?
that's just what popped up first. I think
Yeah,
you
you can
wanted to we
Mhm.
can?
go ahead.
Okay.
Go
Well, I
ahead.
was just
Yeah.
going to ask you about the best car armor because that's something that everybody knows you for, and you're kind of well known for that. And both of my daughters really love The Mandalorian, so uh, they're like, "Mom, you have to ask him about the best car armor." I'm like, "Yeah, okay." But
Sure.
I wanted to anyway, and I just wondered, like, what is it actually made of, and how did you come up with the idea for this?
Well, the armor material, and this is, just in conversations, I think I explained it before that there were some folks involved in the Lucasfilm and Star Wars enterprise, the Star Wars culture that had communicated with me years ago. And they had started using this to discuss armor because we were discussing high performance materials and some of the proprietary things we were working on. And one of the high performance materials that we have is it's a very lightweight armor and high temperature alloy that we can use in aircraft structures. And it does have an element that other materials do not have in it to enhance the structure. And I'm sorry, I can't share the element right at the moment, but
That's
it,
okay. I'm not
element.
gonna try. I'm not
And
gonna try
so
to get you in trouble.
it's an alloy, and it's a proprietary alloy, and it will be found in some of our future fighter aircraft and spacecraft.
Oh,
And
cool.
we're increasing the content, but it's one of these magical alloys that has higher strength, tensile strength than titanium and lower weight than aluminum. And
Wow.
when you talk about this stuff 20 years ago or 25 years ago, it was pretty exciting to the Star Wars community. And I don't know if it I think a lightsaber could probably cut it, but in future iterations, we'd like to have it lightsaber proof.
Yeah,
Yes.
that's what you have to build next, eh?
Well, yeah, that's one of those projects we've been working on for a long time, and it has a lot to do
Oh,
with frequency and phase, and
yep.
lightsabers, pretty cool. Cutting with light, big important
Oh,
technological.
yes. Can
So
be done. It has been done.
that's yeah.
So how did you come up with this? What made you even be able to come up with this?
Well, there's two things. Really, I think that there was another element to it because we've been working on body armor for a long time. And I mean, like 20 some years. And we do have the whole project actually came out of something we called STAG, which was called Stavatti Tactical Armored Garment. And this was on our website years ago. And the whole idea was really to put together a suit of armor that could be worn by a pilot while flying a fighter. And it would also be a pressure suit and a G suit. So it has elements of all of that. And even if you want to go into the more fantastic iterations, have components similar to the Dune still suits. So the idea is that you would be protected in the cockpit in case you suffered vehicle damage. If you ejected, you would have a higher survivability. And if you landed someplace after ejection, you could continue the fight and survive in the middle of nowhere. And so that was the general idea. And this is, something mass produced and sized. And actually, there's a contract we recently received. It's one of the orders we received, purchase orders for a next generation body armor, integrated body armor suit, similar to what the Mandalorians wear, and that concept that would incorporate these elements. And so it even gets into the jetpack component. We do have different technologies, like what we're using for our propulsion system in the hover car and some advanced aircraft can migrate directly to a jetpack. And of course, Bell Aerospace up here in Niagara Falls developed first jetpacks, the first rocket belts. That actually worked, and they demonstrated a lot in the 60s and 70s.
Yeah.
But they're really cumbersome. And so the other issue with a rocket pack, like you have that Boba Fett or the Mandalorian wears, is you could really roast your buttocks. And you don't really want a rocket pack. You want some type of flight pack, but not a rocket pack, really.
Yeah.
Yeah, that doesn't sound comfortable at all. Is
So
this could this also be like a Faraday cage in a way? I've heard that suits of armor were once Faraday cages.
I think there's really too many gaps and holes in it to do that, because you have
right.
like you have a body stocking underneath, more or less, and then there's some elements. I mean, when you really dig into it, the costume armor depicted that is worn in the Mandalorian isn't exactly like you would fit a real body armor.
Right.
And it's as you study what they do in the show and the series, there's a big difference. But
Yes.
But what we're trying to do is really have an integrated system, and we've already designed some of the early suits. We did that over the years, and so that's a lot of fun, and we don't advertise it too much except in our marketing literature for defense purposes. But as fighter planes come out, one of the big elements of next generation fighters is helmet mounted display systems. and helmet mounted displays that actually allow you to move your head around and eject without dying. And that's a
Yeah,
big problem because a lot of the helmets that are out have had some, serious issues with respect to whether or not a pilot can survive ejection and not get their neck broken.
Oh,
So those are all important aspects. So really having a cool, stylish suit that actually works, is functional, and made out of a material that really will protect you. And it's kind of
yeah,
over the years, there's a few different aspects of armor, and one of the things we've concentrated very heavily on is foam metal sandwich materials,
right,
uh, and that results in a different kind of body armor that's a lot more robust, and it's more like a suit that you'd find in a lot of manga or Japanese anime, and the Gundam type stuff and all of
right.
that. So that's something else that we're working on, but it's not really suitable for the cockpit, but it's definitely a better way of solving this. So this would be, level 4 plus armor as far as combat grade, ballistic grade goes, but it's not something that you can use in a heavy artillery environment.
Right.
right. Makes
Um,
sense.
is it? It looks like it's hydroformed. Is that that's how you did that?
Well, yeah, with this, this particular image, it does look like it'd be stamped out and hydroformed, and that's correct. That's how you can do that. Rather than now in the show, they show it being cast, and
Mhm.
in reality, we wouldn't cast it. We actually would form it with a press.
Yeah.
So,
Um, yeah, that's really cool. The other question I have about this is I've heard that the hover car is in some of the Star Wars movies. Is that a true statement or not?
no, the design for the hover car isn't. That's something that we've been real careful with, and it hasn't made it into any science fiction yet. Some of
Okay,
our designs, like our early SM-31 Mamba fighter, that's been the basis of some designs, and you can see that the Razor has inspired some things. And going kind of back to the history of the Razor, that configuration came out in about 2004 initially, and then we
okay,
we resuscitated it or revived it back in 2010 for the Air Force Next Gen TAC Air requirement, along with about 20 other designs, and uh,
right.
and then it was solidified as kind of the design of choice in 2012, and it's been going through different iterations ever since. And so it's we're on our final iteration now, which is a little bit of a different shape than depicted in all of our presentation material, but
Okay,
it's really along those lines. And so that, I think, has inspired some different designs seen in Star Wars over the last 15 years. And
right.
so it's been really pretty neat. And the Mamba, especially, we had that on our website, an early Stavatti website back in '98, and that kind of took off and got interest. We have some new stuff on the Mamba that we'll be putting out over the next year. But the Mamba is really intended to be the kind of the last great fighter to use the F-110 series of engine found in the F-16. And
Okay, yeah,
so it will use an F-110 GE 132 that puts out about 32,000 pounds of thrust.
yeah.
Uh, it's intended to be a stealthy F-16 replacement, and
Okay,
have a price of about $35 million. So it's very affordable compared to an
yeah.
F-16.
Very
It-
affordable.
and
Yeah, that's
it's
amazing.
it's a cool looking little vehicle, and then we'll have a version of it that will go to very high altitudes, and that's the basis of our official space fighter project. So that's kind of cool.
Oh, that's awesome.
Space Fighter Project?
Yep. Yep.
Wow, that sounds amazing, doesn't it?
Yes.
So so we have two big space initiatives. One we call the Space Fighter, and the other is our space transport. And the space transport is really, I think I might have told you this before. It's viewed as a C-130 for space,
Yep.
and it'll carry kind of a standard Sealand container. So that's one of our big initiatives. And then the Space Fighter is really like your X-wing fighter or your Colonial Viper or whatever you want to call it. It's sort of along those lines, and so that's something cool that we're working on too.
So that would go from, you could probably vertical takeoff and landing and then just go right straight up into space with it from here.
Sort of, yeah, yeah. That's the idea. Would incorporate a lot of the elements of the hover car, and so that could do that, and you could theoretically sell it as a sport jet, but
Right.
would
Is it
be
still considered, I'm sorry, I didn't mean to interrupt.
no
Go ahead.
I was just gonna ask, is it still, would it still be a rocket or fueled by rocket? Or would it be,
These will use rocket engines in the sense that you're throwing thrust out the back, but it's
okay,
actually more along the lines of a variable cycle turbo ramjet rocket. And
Okay.
if you look at, there's a lot of neat stuff that was done in the 60s and 70s by a variety of companies, including Rolls-Royce. And
Yeah.
they were one of the first to propose a hybrid jet engine rocket type propulsion system.
Yeah.
And so that would incorporate those features. And so that's the general thought. Something that when you're in an atmosphere, you're using air for the mass flow that you're throwing out the rear. So you heat up the air and push it out. And then
Yep.
when you get to a high enough altitude, it functions in a rocket mode, where you're throwing out a mass that you bring along with, which could be
Right.
some hydrogen, for instance, let's say, and you're ejecting that. So really you have an onboard heat source, more or less, that's heating up your hydrogen and then throwing it out the back end, and away you
Okay.
go.
So not like ionic propulsion though? Is it different? That's
It is
different.
different. Yeah, it is different. And we are looking at ionic propulsion. And that's pretty cool stuff. But the problem is getting really the thrust up there, because unless you have thousands of pounds of thrust or more, tens of thousands or millions of pounds of thrust, it's
Yeah.
the propulsion system doesn't really do too much for these
Right.
kind of vehicles. So we need some serious advances in ionic propulsion. And so we've got some thoughts on that are, we're exploring. So
So you guys are basically exploring all the bases essentially.
yeah, and
Yeah.
we have a slightly different view of the future of rockets. We do not think that space propulsion will be chemical. We see
Yeah.
we see it as being electric.
Yep.
And
Absolutely. That's wonderful. That's going to be an amazing day. That is because we don't really need the rockets anymore. We do have the technology, I think, to be able to do it other ways. It's just that some of that technology is still locked up in black projects, I think, and that's part of it, right? But
yeah,
it's all coming out.
a lot of it is a lot of what is neat though is there's so much published information, and it's really just a matter of putting together the project, getting it properly structured, properly funded, and moving forward with it. And the challenge, of course, in the commercial environment is that usually investors want to see a return on investment within 6 months, a year, 2 years, 3 years becomes crazy for them. And to do a lot of this work, it doesn't pay out quickly. It takes
Yeah.
3 to 5 some big projects, and it's just hard to fit within the current investment model, which focuses more on flipping something than making a long-term investment.
Yeah. And I guess since we're talking about this, we should talk about the fact that Stavatti was and is still crowdfunded kind of through David Wilcock's thedisclosure.com, right?
A little bit. That certainly helped to a degree. And we're open to that. But that said, we haven't really done a big advertising push or like a Regulation A offering. We may do that. We're not really taking donations. We don't have like a donation button, but we
Yeah.
are working with a lot of private investors, some high net worth people, some different funds. So part of it, yeah, it certainly is. It can be crowdfunded, and it helps, of course. That's great. And we're limited by the Securities and Exchange Commission as far as what we can do
Oh,
as
right.
far as advertising and all that, because we are a privately held pre-IPO company, so to speak.
Yeah.
But that said, yeah, we're still fundraising in the sense that we have a lot of projects and they all need different levels of funding. Some are being funded at earlier stages than others. So
Like you were talking about changing or fixing the hangar doors, I think. Is it on this hangar that you were talking about before?
yeah, that was performed, and that was just for instance, that initiative was about $100,000 to update the hangar doors.
Wow. Oh,
Yeah.
just update them, not replace them, just make
No,
them
we didn't. We
function.
didn't replace them. Yeah, we just made them better.
Yeah,
new insulation and fixed the mechanics so they can open and close.
yeah, yeah, you
Uh,
definitely need that.
They were probably
Um,
pretty sturdy to begin with.
Legia, do you have some other pictures? We have a few more pictures
Yes,
there for
I
Chris. Let's
wasn't
bring
sure
up
which one you wanted me to show next.
I think we just bring them up as they are and we can talk
Oh,
about them
okay. Well, we have
here.
this one, the Stavatti, no fans, no motors, no rotors, no
Yeah,
blade, the hover car,
mhm.
SM 2032.
Yep. So
and
So
that's
then
yep. That's
go
one of
ahead. I'm sorry.
Yeah, that's one of our original ads for the hover car, just announcing that we're doing it. That's an initiative. And that's right. The propulsion system doesn't have any fans or rotor blades, or, the whole idea is to get away from this idea that we're using propellers or spinning bladed things to make it fly. At one point, the original iteration of this was no fans, no blades, no gravity, but we thought that would be too shocking. And so we just no rotors, no
yeah,
blades. And so
that's actually funny because I actually have a screenshot of what you just said there. I have that
okay.
somewhere. Yeah,
Yeah, I think
from before.
we ran that at one point too, but this is
I,
the one I think we published. So
there's
And
nothing wrong
Legia,
with shocking when it's like that kind of shocking. That's a good kind.
yeah,
We need that more
yeah.
of no gravity kind of aircraft out there.
Well,
and
there's
Legia, there's that last line. You should read the last line too because it's really important. I
A
can't see it.
four-seat zero emission VTOL personal air vehicle now under development. So yeah, VTOL, vertical takeoff and land.
yep.
Yeah.
Yep. Awesome.
I was Chris, I recently watched this show about the Navy and their aircraft carriers. They've been filming landings since the very, very beginning, just to show pilots, what can happen when there's an accident and all that kind of stuff. And that's what this whole show is about. But as I was watching it a couple of days ago, I started thinking about you and the VTOL and how vertical takeoff and landing on an aircraft carrier changes everything because it's like a helicopter. And I know that some of the planes do it now, but it's just kind of interesting to let everyone out there know, how it changes things because you don't really need that catapult anymore.
Right. Well, getting into that a little bit. One of our major projects is our SM-36 Stelma, which is a fighter that has a large legacy with the company. It kind of launched the company, and it was a politically incorrect airplane because it was competing with the F-35, and
Wow.
you weren't allowed to say anything bad or criticize or threaten the F-35 program for about 30 years, and that it started in 1995. The next year will be the 30th anniversary of that project and that airplane.
Wow.
And so it's taken a long time for that airplane to gestate, and it's finally entering service in quantity. But I have a very poor opinion of the airplane. And of course, I'm prejudiced because I have a design that competes with it. But
Yeah.
what we've done is we've updated our design considerably, and we do have a vertical takeoff version of that airplane for a very specific customer that has asked for it. And the
Wow.
caveat, when we said we design a vertical takeoff variant, we said, allow us to do it any way we want to do it. It won't
Oh,
have a
wow.
and so it's pioneering the hover car technology. So
Right.
that's a cool way to do it. And it will allow you to have a new type of naval aircraft where you can take off and land. But kind of the key is it isn't going to raise the dust. It isn't going to kick up the dirt. It's not going to lift up women's dresses. It's not going to, have a situation where all these bad things about helicopters,
Yeah.
it will be a lot more noise friendly, a quiet approach comparatively speaking. And the other thing is you don't have the jet blast. And the Harriers are really, I love Harriers. They're really cool.
Yeah, yeah.
They have a jet blast issue. They got four little tubes that put out all this high temperature thrust, and you need to look after the concrete after you take off. So
Oh, right. Yeah, right.
So you don't need any headphones with this to cover your ears. It's
no, it
like a
won't be
kinder,
that.
gentler kind of thing.
Yeah. So, and that kind of gets back to funding. So part of, we do some government projects, and the ideal situation for us is we sell a project to a customer, and that project is funded through that sale, which allows us to do our programs, and we make a
Yeah,
profit, and then we reinvest into the company. And so the hover car project then becomes a spin-off, both technologically and economically, of other work we're doing.
yeah.
So you don't need to hopefully put that much private money into it.
And the Stelma, you were saying last time too that that will also be, like you were just saying, the I guess the tool for all the different propulsion systems that you were thinking about, because you talked about a bunch of different ones last time.
Right. Yeah. It has a nice engine bay, and it has you may have heard of bifurcated air intakes, and that's where you have two air intakes on an airplane to feed into a single engine. We have a trifurcated intake, which is really
Oh,
different. We've got three air
wow.
intakes feeding into it. So it's got a lot of airflow, which is part of its key to efficiency while cruising. And so it's more like an airliner when it cruises. And there's a lot of different, as a consequence of that, there's a lot of room within the engine bay that you can make different versions of the propulsion system and use it as a test bed over the next 50 years.
Yeah, yeah, that is so cool. And you even talked about having different propulsion systems in the hover car, perhaps as well.
Yes. Yeah, that's
Yeah,
correct.
yeah. She brought up this is the Javelin, I think.
Sure. Yeah. So getting into that history, the Javelin was an airplane developed by ATG in Colorado, and they ended up selling their prototype and their tooling and their intellectual property to another party, and we ended up making an agreement with that party to produce this airplane, and so we received the intellectual property, and we were going to submit it as a next generation trainer under the Air Force TX program. And at the time,
Yeah.
we were very excited about that. And as we got more into the design, we discovered we needed to put a bigger engine in the plane. And
Oh,
we ended up learning that, well, at the end of the day, we would be better off designing a brand new airplane to meet that
right.
need. And we became so excited about the project and so excited about the need that we ended up designing a new airplane. And that airplane is our SM-31 Stiletto. And so this
Oh,
this plane, we're not really doing anything with this at all.
yeah.
So it was a really cool project in that sense, and it led to something else. So that's where that whole history is.
It's funny because when I first found that, I actually thought that it was your personal plane.
No,
Just,
no, unfortunately, I don't think this airplane is fully intact anymore. I think the
oh,
prototype
wow.
was kind of disassembled. I'm not sure. I know it. At the time we were focused on this project, it was located in Florida, I believe.
Huh.
Okay.
I'm located in Florida, so I could go see if I can find it.
I want to, yeah, great.
So now we have the hover car.
Mhm.
And I actually had an artist kind of work on this, and I added
Good.
Stavatti Aerospace SM 2032, the hover car, to it. And
That's
yeah,
good.
this is something, a screenshot that I captured, what, 3 years ago, more than 3 years ago
Sure,
now.
sure.
Yeah. Is this indeed the hover car design that you did in '87?
It is. It's a hand drawing that I did years ago while in the seventh grade.
Wow.
It's
Seventh grade.
You did this in the seventh grade?
yep.
Oh my God.
And
That's
so
amazing.
Wow.
it's really it now we haven't revealed the current design. Of course, the current design is a modern iteration. It's evolved quite a bit, but it is still very indicative of this. And I'm trying to make sure that the design looks as much as this as possible. Of
Yeah.
course, this is a little more stylized. And when one of my challenges as a designer has always been combining art and style and aesthetics with practical
Yeah.
functionality.
Yeah.
And
Yeah.
there are two driving factors in that. One is always the propulsion system, and the other is people. And so, how do you fit 4 people in a craft shaped like this so that they have enough headroom and it's comfortable and they're
Yeah.
not so, you know.
Right.
And I think the design, when we release it in the not too distant future, this year, we hope to release it very soon.
Yay.
Oh, wow.
We'll be, we'll have designs, we'll have 3D models, we'll have desktop models, we'll have stuff, and then of course the prototype getting cranked out. And we've got way too many vendors that want to prototype for us. We have lots. I think we got 3 today saying, "Hey, can we prototype this for you?" And I said, "Well, we can see what parts you can make and all that." So,
Does it
Wow.
still have the wings that fold down?
oh yeah, we'll have the folding wings. We have
That's awesome.
all of that. So and the goal is really it has to fit in your garage. It's going to gobble up your whole garage, unfortunately. But, we'll say, "Hey, you have one of these. Why do you need another car?"
Exactly.
Exactly. Um, going back to the 7th grade, is the story that in the 8th grade you approached the Air Force? Can you
Yep.
tell us a little bit more about all that?
Sure. Well, that was for what was then. Well, okay. So I love to design a lot of different vehicles. And of course, fighter airplanes are kind of the hallmark. And especially when you're a kid, you love fighter planes really early on.
Yeah.
And so I'm always drawn, cool fighter jets. And so I really focused on a fighter aircraft configuration. And that became our entry into the multi-role fighter program. And so that was a program that predated the Joint Strike Fighter. And so between basically 1989 and 1993, which was essentially that Bush era, really.
Yeah.
I was extremely active then. I was excited. Heck, we even this is another cool project. It was led by what's his name, the vice president at the time, the vice president under Bush. He, why can't I remember his name, Mr. Potato?
Oh, the one that couldn't spell the name. Oh,
yes, Dan Quayle. Dan Quayle.
yes.
Yes, so Dan Quayle had this initiative for a spaceship to go to Mars, and this was kind of a hybrid NASA initiative. It wasn't just NASA. I forget the whole thing, but this was a spaceship. This was an interstellar spaceship to go to Mars. It wasn't a rocket program. It was a really cool, reusable. It was like, let's go build the Discovery from 2001: A Space Odyssey to go to Mars. And so I entered that. We came up with a design and everything, and it was really a cool project. That was probably about the same time as the multi-role fighter. So that whole time period was really busy for me as a teenager, as a high school student. And
so you, sorry to interrupt, but you were still in high school at the time, is
yeah,
what you're saying? Wow.
Yeah, I graduated in '92. So
Okay.
that was that whole era. And so I was always being asked, probably from the 10th grade on. So Chris, you're building an airplane. Tell us more about this airplane that you're building. And I said, well, I can and I can't. And I kind of incorporated some of the elements into my physics professor, Mr. Brandt, was really cool at the time. He gave me 2 independent studies that tied into spaceship and airplane design.
Oh,
And
wow.
this was before cell phones, and so I had access to a phone and stuff like that. And so while I was at school, I could work on these projects, and that was helpful a lot when I wasn't doing stuff out in the field and at home. So it was, I got to have kind of a day job at school for a few hours every day. And
Wow.
that was cool. And So, but yeah, we submitted a multi-role fighter program submission. It did get funded. I can neither confirm or deny that 2 YFXX prototypes were built. And
Oh,
so that
wow.
was kind of the basis of what launched everything. And those airplanes are the kind of the foundation of what evolved into the Stelma, although the SM-36 is kind of a watered down export configuration of that.
Okay.
The program was then essentially canceled under the Clinton administration. The Clintons took a different approach, and the focus then, the original plan was we would have a lot of different new airplanes that would be manufactured. We'd have a replacement for the F-16, an F-18 replacement. The F-22 would go into production, or
Yeah.
F-23. It wasn't selected yet at the time. It
Right.
wasn't rolled out. And then we would have a new airplane for the Navy to replace the A-6. That was like the A-12. And one by one, these different programs got canceled. So the Navy A-12 got canceled, multi-role fighter got canceled. The Navy never got an F-14 replacement. They were going to have a Navy advanced tactical fighter that never came into being. They didn't get the Super Hornet, the Super Tomcat, that was canceled. And
Right.
of course, the F-18 was never replaced. Instead, they got the Super Hornet, which was then going to also replace the F-14. And so we went through this whole phase of, instead of doing a lot of new development, we're just going to take what we have and we'll have F-22s. And then to replace the A-10, the F-16, the Harrier, the F-18, all these other planes, we would build this one airplane. And they called it the Common Affordable Lightweight Fighter at one point. They called it the JAST, the Joint Advanced Strike Technology Plane. They
Okay.
were British. They got a Russian Yakolev 141 over here. And so eventually it became the Joint Strike Fighter program. And we submitted our design to the Joint Strike Fighter program. We said, hey, we've got this airplane built. Oops, I'm sorry, I said that. So we have this design and it could satisfy this mission. And you should include us in the F-35 program as a competitor. And the response we got was, well, we'd like to, but we already went through one phase. So how about you compete under EMD, which is engineering and manufacturing development, which would be full and open competition. And I said, okay, we'll compete for the EMD. So thank you for letting us compete. And then when time came to compete, they restricted the solicitation to Boeing and Lockheed. So it became a
Wow.
do. So it irritated me, and that was about that. And so we focused on other things until it became politically expedient to continue this program as an export airplane for other countries and maybe our country. So that's where we're at today.
Wow.
The F-35, you have something to do with the helmet on the F-35?
No, nothing.
Okay.
To do with the helmet. Yep.
Nothing to do with the F-35 at all. I know your opinion of
Oh,
it.
yeah, no, nothing went on it. I was the person saying, there's this wonderful new canopy technology out there that's bird strike and bullet resistant, and it injection molds the canopy and it will reduce canopy costs to like $1,000 a unit. And they said,
Wow.
oh,
Yeah.
that project is too far along for that. And I said, oh, okay, too bad.
Wow. Speaking of which, some of that canopy heads-up display.
Oh, big time. Yeah. Yeah, the idea that the whole approach we've been pushing for a long time is having the display not on a heads-up display or even on your helmet, but actually on the canopy itself. And so that's kind of cool. And if you like widescreen televisions, you could watch your TV program on the canopy. But it's and what's made that possible these days is the organic LED technology. So
Okay.
you really have an LED built into your canopy.
Right. Oh, wow.
So there's all kinds of neat things that come out of that. Like, for instance, one of the big problems with canopies is, especially like on an F-16 that has a bubble canopy, you have the sun that can be a glaring spot, in your
Yeah.
canopy. And
Yeah.
so you can actually have this canopy black out the sun in that area. So you
Oh,
have like
wow.
you have like a total eclipse right where that sun is. Flying through. So no more, the old saying was watch out for the Hun in the sun. from World War I, you know, and
Oh,
this,
Yep.
yeah.
this eliminates that problem of being blinded by someone coming at you out of the sun.
What
Yeah,
do
for
you
sure.
what do you think of thought-based technologies, and do you foresee that happening anytime? Thought like using them for
Sure.
driving?
So we've had brain implantation technology for a long time. And one of the directors on our team, Stu Cart, actually made brain implantation chips. And he has a
Wow.
sample, and it's kind of a kooky story. I asked Stu, I said, you know, what were these for? And he said, to eliminate space sickness. I said, okay, how do they work? Well, you implant them on the brain. Well, how many does it take? Oh, well, 10 to 20. Oh, okay.
What?
Well,
Wow.
was this used much? Yeah, it was used a lot. So,
Wow.
so you put that whole string of sentences together and it becomes a very confusing revelation. So,
Yeah.
No kidding.
but
Wow.
but that said, so that technology, you know, I first saw the physicality of it about 20 years ago. That
Right.
particular brain implantation chip. And
Wow.
so, and I know it was around a lot. I mean, this was one of the older ones. So I know that it's been around a long time, probably 30 years. I know that, you know, we've had the Neuralink come out, and
Yeah,
that sure is neat. And of course, if you remember Firefox, the Firefox from that
I
movie
do. I
was
do. Yeah.
flown, you know, you had to think in Russian
Yep.
and fly the plane. And so, yeah, we can do that. Is it a good idea? Um, yes and no. I think there's, you know, the human mind's kind of pretty random. We think about a lot of different things. Sometimes I'll,
Yeah.
or
It could be
sometimes we don't.
dangerous.
Yeah. It can
Yeah.
be dangerous. Um, so it's feasible. I mean, we could do it, and I think there's some elements of it that we can incorporate. But I don't like the idea of putting things into my head, so that
Me
so,
neither.
you know,
Exactly.
a helmet a helmet that can read your thoughts, I'm okay with that. But you know, and
Yeah.
that does, I think that does exist. I'm pretty darn
Yeah.
sure that it
Oh,
doesn't
yeah.
exist.
Yeah.
We've got a
I,
lot of ways to measure thoughts. So
my
Yeah.
father was in NORAD and he took me to Firefox. I remember I was like 13 or something, and he told me that this is real technology.
yeah.
He said, this is real. And I was like, really? Wow, you know, kind of thing, right? Um, can you tell us a little bit more about it was at July 20th of 1994 when you started Stavatti?
Yeah, that's right. Yep. Stavatti Corporation, Minnesota.
And it that lined up with the moon landing, did it
Sure
not?
did. Yeah, it
Yeah,
did.
it was anniversary of some
It
kind.
was. Yeah, it was the moon landing anniversary date, right?
Huh.
Yeah. Why did you? I mean, it's very cool, but how did you sort of choose that?
Because the focus is to go to the moon and beyond. Always been the mission, you know, to
Awesome. That's the answer we want to hear.
yeah, the whole airplane business. I mean, I've gotten more into the airplane business because I love airplanes, and I think they're really great transportation, and I think a lot can be done in the field. But the real mission is you build airplanes to fund the space operation, and
Yeah.
there's a lot of parallels between airplanes and spacecraft. So, you know, it's a good start. And most of our spacecraft, probably argue all of them, have been built by companies that at one time or another built airplanes. So
Cool. So what you're saying is there is things that are built out there, is what you said?
oh well, yeah. I should well, I mean on the easy thing, not to get into the really esoteric stuff, but the on the very simple terrestrial things, you know, McDonnell Douglas made the space capsules. The lunar lander was made by Grumman. The
Yeah.
Saturn,
Yeah, that's right. Yeah.
the Atlas rocket was made by Convair, and which became General Dynamics, and the Titan Martin Marietta Martin aircraft. At one point, just looking at the history of aviation, after World War II, the Martin Airplane Company decided the future of aircraft isn't aircraft, it's rockets. And so we're just giving up the airplane business and we're going to make rockets. And so they focused
Wow.
on rockets. And so when Lockheed and Martin merged to form Lockheed Martin, Martin by then was the rocket company. They weren't the airplane company anymore. And of course, Lockheed was the airplane group. So
Yeah, because we had, isn't it the one they use for firefighting, the Mars, I think it's called. There's
yeah, the
one
Martin
in,
Mars. Yeah, yeah, that's a Martin. Yeah, Martin built a lot of seaplanes. Yeah, the
yeah,
amphibious.
that there's one or a couple in Canada. I think they're out of
Yep.
Victoria that they use for
Yeah,
firefighting.
yeah,
Yeah.
they still do. Yeah, the Martin Mars, the Privateer, the Mariner, all those airplanes. Yeah, big
And
sea.
is it SM-100, that transport, is that a firefighting setup too, or do you have a different
Yes, it
plane for
is.
that?
No, that's our SM-100 AT, and we'll have that on the website shortly. And we're doing a lot of website updates. But
Yeah.
that airplane design is our cargo plane and fire bomber, and it puts out forest fires, and it should do very well at that role. And we'll have a few different versions of it. We'll have an autonomous version, and we'll have a vertical takeoff version, and it's all kinds of cool things.
Oh, wow.
That's
A
kind of
vertical takeoff version of that big, that's a big plane too, isn't it? It's a big plane.
that's the big plane. That's about 100,000 pounds. So that's
Wow.
really a significant vertical takeoff achievement. So
That's a
That's impressive.
challenge.
yeah,
Yeah, that will
and
be quite
so,
impressive.
so
Uh,
that's where all this hover car related technology, it backfeeds into conventional aircraft.
that's
Yeah,
awesome. That is
exactly.
something to really look forward to. Do you know if there are any kind of aircraft that can also go underwater?
Not that I know of that are in production that are made by people. So I don't,
Okay,
yeah,
that's a good answer.
That's a great answer.
Well, we got to work on that.
yeah. Yeah. There are some designs. I know of designs. There's a lot of cool stuff. I've seen designs for submersible aircraft carriers. That's pretty neat too. But
Yes.
Yeah, definitely. We have any more pictures there, Leach? I think there
Well,
might be a,
if you want, I will put up some more. Let's see what we've
yeah,
got here.
there's
We didn't do
the
this
hover
one
car.
yet. Did we? No, that's the one we were just doing. This one.
Yeah,
Yeah.
this one. Chris, this is I'm in a group called Model G for Gravity Vertical
uh-huh.
Ether Research Group. And Paul Laviolette, who is the physicist, he was a quantum physicist and an astrophysicist. But this is called the Aquarian Monopole Elevator. And the reason why I'm showing this to you is because he designed this, I think, in about the 80s, 85 or something like that. And it uses a double hull design.
Mhm.
And I know that some of your stuff does too. So I was just wondering if you could talk
Yeah.
about any of that, the double hull design.
Well, the original design for our Stelma aircraft was a double hull, and it had a band pass external skin and a non-band pass internal skin, which means that radar could go through the external skin, but it would be
Yep,
stopped on the internal skin. And in between, you have a plasma.
yep.
And that plasma would be used as an active radar absorber. And
Wow.
in addition to that, when you have a double hull with the plasma in there, you could do other cool things theoretically. And so it kind of ties into some of these ideas that you can, who knows what you can do with a double hull and a plasma. And as soon as
Yeah.
you, the challenge
And
is it's a little bit harder to manufacture. It's more labor intensive, of course, and you get a lot of EMF going on.
does Stavatti own patents on double hull aircraft and spacecraft?
Nope, nope. We never
Okay,
published any of that.
okay. Interesting. Yeah, I just thought I'd bring that up and show that to you. It's something he didn't patent or anything, but something that we came across in one of the meetings, and it just kind of perked my interest and wanted to ask about the double hull thing.
It's
I
a
had a,
pretty neat approach. We might resurrect that again in the future.
oh, okay. Well, that's interesting. I have another question about last time you talked about shielding technologies.
Mhm.
And one of the things that I do, Chris, is I design vacuum tube amplifiers.
Okay.
And there's a very specific vacuum tube amplifier that we design that doesn't have an output transformer.
Okay.
the tube is driven directly to the speaker, and the tube that I use has 1.2 amps of current. So it's major current. The tube was designed for, it was the shunt regulator in the very first particle accelerators that we had. So
Okay.
it's a big giant power triode. And it's very similar to the one that they use in the MiG, which is the 6C33.
Okay.
And okay, so, and I also use that tube. And I remember you talking about having that radar in front of the pilot, and how do you shield them from that? And so can you talk a little bit more about those kind of technologies?
Like the radar shielding technology, or
Or just, or yeah, or just shielding in general, because you know you've got a big power supply, you've got tubes, you've got high voltage. Is there anything that you can do to, you know, protect the pilot essentially?
well, there is, and that does get into titanium diboride a little bit. That helps with radiation protection. And this is something
Oh,
we studied a long time ago. And I don't know if you've ever taken any measurements while you're on a commercial airliner, and I can throw a picture up, but I have a lot of footage. And you know, I just came out of Denver, Colorado area, and I was up on Hurricane Hill for a while. And that up at 8,200 feet, you get about 35 millisieverts a second. At high altitudes, you'll get like 3.85, and you get into a situation where you're basically being cooked. You're getting
yep,
higher levels of, if you went to Chernobyl or Fukushima now, you'd get lower levels of radiation than you get on a commercial airliner. And so this
yep,
is at 35,000 feet. And it does vary with altitude. So this is a big issue. And it's one of these things
yeah.
that I'm really tempted to throw this up on YouTube or Twitter or whatever else and say, hey guys, one of the reasons you want to buy our airplanes is because we're not going to cook you. And Boeing,
Yes.
no, Boeing and
Well,
Airbus.
guess what? You just put it up on YouTube, Chris.
Yeah, yeah, I should probably share the video with you. But that said, you know, the big thing is how do we resolve that? And so that's one of the reasons we're doing foam metal sandwich. It's one of the reasons we're going to. There is a material which is someone else's material that was being pushed as a sarcophagus material for the Chernobyl reactor.
Okay,
It's a radiation absorber, and it also attenuates EMF. And so in
wow,
addition to having a Faraday cage and you know, you actually do want to have materials in your aircraft, especially around your avionics, that may be radar emitters, especially
yeah,
to keep you from being cooked. And so, you know, the story goes that the higher the altitude, the more your radiation exposure. And many of these over the pole, high altitude, 50,000 feet cargo airline pilots, they get higher cancer rates. And there
wow,
was even a study that came out that I have a copy of the study, and this is a serious, it's an Air Force study. There are other studies that show how the radiation exposure at high altitudes is very detrimental, especially if you're flying for long periods of time.
yeah.
So
Yeah, and I didn't really ever think about that. That's such a great thing that you brought up to, you know, let everyone know that there's possibilities of that.
yeah, it's funny when I had my Geiger counter on sitting next to a passenger on a commercial flight some time ago. He said, "What's that?" I said, "It's a Geiger counter." He said, "What's it doing?" It's telling us we're in a high radiation environment and we should get out. Turn the sound
I
off.
bet you the people are like, "Oh my God."
Nobody seemed to care. You know, it's
Yeah. They're like, oh, he's just some weirdo.
yeah, yeah. I've got you know, I'm not going to plug the. Where's my Geiger counter? Let's see.
Oh, you've got it.
Oh yeah,
He
I
car
keep it at my desk. So
he carries it with him.
yeah, so not to plug anybody in particular, but here's my is it showing up? My Geiger
Yeah,
counter.
well, your
Right.
background's, yeah,
Yeah,
the closer you bring it, you can see it. But yeah, you could see it.
yeah. Anyhow, it's a SOAKS quantum dosiometer.
I'll have to check that out.
Yeah.
Definitely.
I would like to have one actually, to be honest, because you never really know.
Yeah. Yeah, that's for sure. I think there's a couple more pictures, Leja. There maybe
Oh,
the
there's
one with
one more. There's only
yeah,
one more picture,
okay,
and
the
it
date.
is one that if I can get rid of this one, I don't know. I don't know why that one's still up.
Oh,
This one.
well, there we go. You got it. Um, we talked about this last time, Chris. I asked if you were at the meeting with Donald Trump when just before the meeting, David Wilcock, when I took this screenshot, said,
Oh, yeah.
"I have not met yet with 45, but I've met everyone else." And then he
Okay.
went off to the meeting. So, were you in the room maybe when he was filming this, or were you were probably close?
I was close, but no, I wasn't in the room with him, but I was with him that night before he took this picture, and well, probably even after. But yeah, so that was when he actually stayed at the Trump International Hotel. I think he was there 2 nights. So we were there. Yeah, that was pretty neat.
Yeah, and that was October of 2020 when you the the David bought Stavatti or
Yeah,
the
he
yeah.
he had yeah, he became an investor and a shareholder and a director and all that. Yeah.
Yeah, he's the director of advanced technologies, is he?
Correct.
Or
Yeah.
yeah, yeah,
Yeah,
yeah,
which is pretty cool. You know, that's
yeah. And it was a year later that I had the Zoom call with him,
okay.
and then the very next day I posted the theory of anti-gravity according to subquantum kinetics and Paul Laviolette on his Halloween forum of it's
Okay.
October 31st of 2021. And
Mhm.
it ended up really oddly number 51, which is kind of strange, right?
Right. Yeah, exactly.
But cool. Must say that it's cool.
Yeah.
Going back to that, maybe you could talk a little bit more about Pete Peterson. He, I always want to know more about Pete. He was just amazing.
Oh goodness. Well, what would you like to know exactly? Is there any
Well, I guess it's the story. Like what I want to get out to the people is the story of how Stavatti started, because it was Pete that introduced you to David Wilcock, right?
true? Yeah, true.
Yeah,
Well,
yeah.
so Stavatti had started in '94, and so we had known about Pete some years after it started, and Pete was really focused on exotic technologies. And more importantly, part of the exotic technologies was the scandium aluminum work. And so he
Oh,
was part of
wow.
the Ashurst technology. And Ashurst was kind of a unique organization. There's a lot of rumors about it, but it was it was a privately funded, CIA funded, Air Force funded initiative to
Okay.
export technology from the former Soviet Union, and it concentrated on technologies out of Ukraine. And so they
Oh,
had CIA aspects of it. They had Air Force people, and some of those Air Force people who were associated with it later became members of our team. And they did a lot of great tangible things. They brought the scandium aluminum to the United States, and it entered into like Smith and Wesson's Timatic series of firearms, their handguns. It
oh, I
entered
didn't know that. Wow.
yeah, the Eastman baseball, it became baseball bat material. It became bicycle material. It
Wow.
was given to McDonnell Douglas for McDonnell Douglas operations. And so, you know, this was something that we discovered early on, that Russian MiG fighters had a strange corrosion occurring when we would replace parts with traditional aluminum, like 20,
Yep.
25, and 75. And we found out they were using scandium. And this was something they were doing in the 60s. I mean, like MiG 21s have scandium aluminum in them, and our planes did not. You know, this is a new thing.
Yeah.
We still don't really use it in any large quantity other than with Stavatti. And so
Hmm.
that was part of the Pete Peterson element. That was the real tangible. He was over in Ukraine quite a bit, bringing over technology. And when I traveled to Ukraine years later to meet with the laboratories that were working on that technology in Kiev, he ended up the director said, "Well, are you with Mr. Miracle?" And I said, "Yeah, that would be Pete. So yes, I'm with Mr. Miracle. I'm over here to follow up." And he says, "Well, it's been some time, and we've developed a lot of new things." And so that was pretty exciting. And of course, this was before the war. I think this was probably back in like 2015 or something like that. So
Yeah.
there's been ongoing work, and Pete was still alive at that time. So of course I relayed the whole story to him. He didn't travel to Ukraine on that trip, but that was sort of the kind of the beginnings of that relationship. And then he had introduced us to a company called Omnigon, what was left of it, which was really you could say it was an AI company that was developed in the 80s and 90s. And it was ultimately a division of General Dynamics.
Oh,
And
okay.
Dynamics had sunk a lot of money at the time. They put about $40 million in, and the government put a lot of money in as well to do what was the beginnings of artificial technology using something called hyper knowledge. And this got into a lot of interesting things. We exploited a lot of Russian technology. And part of one of the things that Pete talked a lot about was Zagalkin algebra. And the Russians didn't have sophisticated computers like we did.
Yeah.
We were very
Yeah.
good at processors that were very high performance processors. The Russians used much less complicated processors, but they used very sophisticated algorithms and
Yeah.
algebra. And so they had a different approach to mathematics. And so that was sort of the key to our interest in that type of AI at the time. And so we were combining topology with Russian algebra with other approaches to math. And so that was something that Pete was really good at integrating. And there were other people too. One of our persons, Peter Ostapchenko, was involved in that. And
Yeah.
another name to throw out is Ken Happel, who's still alive today. He was kind of the genius behind the topology of hyper knowledge. And even today,
Wow.
this is stuff that is still groundbreaking today.
Yeah.
And then you get into the optical computing, which was another thing that Pete brought in, and the work of John Haidt, I think is the name, and that led to a whole new company, and it was very exciting. And the funny thing is that there was a company called Cyberdyne that was created years earlier.
Yep.
That was the Pete
Yep.
Peters company, and
Yep.
since then, of course, Cyberdyne's been used by the Hollywood folks, and Pete, of course, had a lot of influence in that. I mean, one of the neat things about Pete is he had some of the pistols from Battlestar Galactica.
Oh, wow.
He knew Glenn Larson. He said that Glenn Larson was the Sunday school teacher for his kids and stuff like
Oh,
that.
What?
wow.
So I
Really?
don't,
Wow.
I don't know. No, that's what he said, but he did have a Battlestar
Wow.
pistol, which is really pretty cool. And
Yeah.
so
That's
there was
interesting.
a lot of neat stuff about Pete. So
Yes.
Yeah,
Well, thank you
definitely.
for spilling the beans on all that. That was
sure.
interesting.
Yeah, it's a mouthful. Yeah, you might hear from Ken Apple. Ken, I went to I need to talk to Ken. I really need to contact him. But I went to a class he taught. It was a little class for 3 people, including one. I was there and 2 others. And it was a 2-day seminar. And I learned more in that 2-day seminar about the nature of the universe than you would learn in a year of college. It was just
Yeah.
Wow.
Oh, I
No
believe you.
kidding.
it's just boom,
Um,
boom, 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 boom. And
Wow.
the electric universe, as I've heard you say, right?
yeah,
Mm.
that whole thing, and the topological view of things, and his opinions, some of which are really pretty amazing. So he's out
Yeah.
there.
Cool.
Sounds fascinating.
So that company was a real company, and Pete worked with the movie people then on Terminator, kind of? Is that like,
I
how did
think
the name end up being on the
I
movie?
yeah, I think he probably had some in the back end of that film. I think him and some people he spoke with kind of influenced that, and he was
Yeah.
big into the Terminator robot and that whole idea. And I forget, I think it was Terminator 3 that came out. I got to see that with Pete at the time. That was
Hmm.
kind of
Wow.
into
Oh,
Terminator.
that's cool.
Yeah, there were a couple of reasons we had to see that. I guess there was going to be one of the vehicles he had sold to Arnold Schwarzenegger supposedly was going to be in the movie or something.
Wow.
yeah.
something like that. They were doing a lot with Pinzgauers at the time, so that was a Swiss Army vehicle.
Hmm.
And he had a bunch of them. He was a Pinzgauer dealer for a little while. He had like 6 that he was fixing up and selling and
Oh,
driving.
wow.
So it was
That's
cool.
interesting.
Yeah, he always had a lot of neat stuff. So, and
Cool.
military hardware and all that.
And Pete Peterson and Ken Shoulders. What else can you tell us about Ken? I know that last time you said that you thought that Ken's cancer was caused by working with some of these charge clusters, as I call them.
I think there's a chance of that. Yeah, I really do. And that's part of, because it wasn't just him. There were other people that had developed different kinds of cancer after working on this technology, especially up at, I don't want to name any specific people, but there has been a lot of work on charge clusters, and I think you really do need to monitor the energetics if you're doing any laboratory work. And that's what we're really focused on, having a safe environment for these studies. And
Yeah.
but Ken was another person that I can't speak highly enough of. He was pretty brilliant, and actually in one conversation today, Ken was often visited by the Office of Naval Research, and as he explained, they'd come to visit and they'd look at what he had and they'd kind of leave sort of befuddled and confused and not know what to do. And and years later, this is over a course of maybe 20 years. And eventually, a lot of the patents that we see coming out for exotic technologies that the Navy published, that are pretty now widespread and famous.
Yep.
They're very, very indicative of the work of Ken Shoulders. And so it kind of seems like the Navy maybe finally paid attention and figured out that there's some merit in this.
So these are the highest patents that you're talking
Correct.
about. Yeah, exactly. And
Point
I know a little bit about them myself, as a matter of fact, too. So yeah,
So
that's very cool.
Ken's work is largely well published. If you don't have a link to his papers, I can share it. It was meant to be open source. So it's not like we're hoarding it or anything.
I would love
awesome.
to actually get his original 54 pages that you talked about. That'd be awesome. That'd be awesome.
If you can send a link to that, I will put that in the description of the video.
Yeah, that'll be fine. Yeah, we host one on our website. I know he hosted one on our own.
Okay.
So we have a link, and there are some
awesome.
cool papers. He has one paper that gets into the Hutchinson effect and what he did.
Yep.
And he has a document, it's real straightforward. Are EVOs are UFOs propelled by EVOs? It's that kind of stuff. EVOs, exotic vacuum object. He had EVOs for anti-gravity, EVOs for shielding, EVOs for this, that, and the other thing. And he was kind of down on the airplane business, sort of. And so he put together kind of a paper for us that kind of called airplanes, antiquated. And he didn't really work on airplanes because, he's working on all this other really cool stuff that it's a shame. So, that was kind of interesting, but he kind of came around in our conversations. I think he liked what we were doing on the airplane side. But
definitely. I was saying in the other group there, the Model G group, that we have something in subquantum kinetics called an etherons, and they're the basic building blocks essentially. And I was saying that if we can make a connection between etherons, charge clusters, and ball lightning, because I think they're all pretty much one and the same, they're just fractals of the others. What do you think about that?
I think that's not such a bad idea. And he put in, I think, parallels to ball lightning and EVOs. I think he has papers about that. And so, the whole idea is of the ether again, is something that's very thought-provoking and ties into some of his work. And you also sort of want to look into Rupert Sheldrake if you haven't already.
Yes.
And, he got into big trouble on TED by stating that the speed of light isn't really constant. And so that he violated the golden rule of the establishment. So
I like
the
that.
rules need to change, and they are changing. That's the beautiful thing about it, right?
Yes.
And that was probably one of the greatest TED Talks ever. But
I
So
love it.
Very cool.
it's neat.
Well, is
Legia, do
there,
you have a, yeah,
I
sorry,
was
go
just
ahead.
gonna say to, I don't have any more questions, but I just wanted to say to Chris, if there is anything that you would like to share about what you're going to be working on or what you're going to be doing in the future that that we could all look forward to, you know, give us a little hope.
Sure. Well, we just this past Saturday, David and I were at the Disclosure Summit in
Yes.
Loveland, Colorado, and that was a lot of fun. I think we had a great show. We enjoyed that,
Awesome.
and we hope to do more future shows like that. I have to apologize. I'm not doing the Contact in the Desert. That's
Mm.
that is a thing, just to let you know.
I think I got it mixed up. I thought that that was the one you're doing because I don't think there was a name originally, and I
Okay.
didn't know about the one in Colorado's. Yeah, yeah,
Sure, but
it's very cool.
and at the one we did, we talked about a lot of different things, but the overall thrust is, we're very busy at the moment working on airplanes and advanced spacecraft. We actually did a spaceship pitch deck a little while ago for the Space Tech Expo that's coming up in a couple weeks.
Oh,
And so
wow.
that was something we focused on. And so, but right now we're kind of concentrating on growing and developing the company. I think what we might want to do is maybe have another Zoom call where I can share some more stuff, maybe in another 2 or 3 months,
Would love
sometime.
that.
Absolutely.
And
Yes,
maybe we
Yeah.
can orchestrate it, and I can throw up some of our videos and some of our new stuff that will be coming out over the next couple months.
that would be
Yeah.
awesome.
I touched on this. One of our big initiatives is our new SM920 commercial airliner. It's very ambitious, but it's very necessary. And so this is a different approach to 737s and Airbus A320s. And so we're really working on that in addition to military fighters and personal aircraft. So it's all three. We're taking on the big boys, and I really can't believe how things have changed so much on the aviation and aerospace landscape with what's really happened with Boeing and Lockheed and costs and quality and safety.
Yeah. Yeah.
And so,
Exactly. Very, very important.
but the
And
radiation,
I started a channel myself. It's called Technology Envoy.
okay,
And I'd love to have you on there as well at some point when you have some time. I'll have my friend Sam, who I don't know if you watched that, the one with me, Sam, and Legia, and Sam was describing being chased by Chinese jet, two Chinese jets while he was in a French airliner
okay,
leaving China, right? He got chased out of China, and yeah,
wow,
so he's a independent journalist for 40 years, so that's what he does, and he'll be on with me as well on that one when you come on with us. That'd be awesome.
well,
Yeah,
cool.
definitely.
That would be cool. Well, we could maybe set a tentative date. We're gonna have our own celebrations on when is July 20th? Well, maybe we could do like a show around July 20th or 21st or 22nd or something like that.
Oh,
23rd.
wow. That would be cool on the 20th, because that would be, like you said, your anniversary.
Yeah, that'd be an anniversary, whatever anniversary celebration that day.
Aw,
How many years would that be then?
That's our 30th year anniversary since we incorporated in '94. So we've got, we might do some interesting reveals on stuff we did in the '90s that could be pretty breathtaking.
Awesome.
So
that would be awesome, Chris. Thank you. Yeah,
sure.
that would be amazing. Yeah, we'll definitely do that.
Okay.
It sounds amazing. Yeah, and then get you back on Potentials here with more updates, and welcome back anytime. Anytime you want to come back and talk about stuff. And the other question is, have you ever been on YouTube before? Like, is this the first time, or?
We just set up a YouTube channel for Stavatti, and we have one of their some 150 videos, and we'll be popular with some more videos. And we're thinking of doing sort of if you remember what Walt Disney used to do at the beginning of his movies, he'd come out, sit at a desk, and kind of talk about the world and the movie. And so I'm thinking of starting to do sort of a podcast kind of thing, sort of a video intro. And we have some other movie projects, and of course, David, he's involved in that. We got some
Yeah.
cool film projects that are under development. So we already did some filming, and some other things that are coming out. So
Yeah,
we're
Levitation, the movie Levitation is what you're talking about,
Yep,
I
that
think.
was one of the things that we're definitely that's in production or post-production or however. We completed our filming aspect of it, and so
Yeah,
that's going on. And we have some videos specific to each airplane that we're doing, and some cool stuff that'll be posted over the coming weeks and months. So
That's
and
amazing. And
John
this is
Hutchison was on that movie as well, too, right?
yeah, he was. Yeah, they have him in there. I think they have some stuff from Stephen Greer. And there's
Oh
some
wow.
question if it's going to be broken up into a multiple film because they have a lot more content than I think that it goes beyond one film. So
Yeah.
wow,
that
that's great.
that's part of
There's a bit of a connection between me and John Hutchison because Carmen Miller, her father was Bill Mueller, and Bill Mueller was in the Hitler Youth, and he actually saw the flying bell, the Nazi flying bell,
oh wow.
and he knew how it worked.
Okay.
And as a matter of fact, I met them. I went to high school with Carmen in Penticton and met her father, and he mentored me. So I've always known about charge clusters and how all this stuff
Wow.
worked,
Mhm.
but I didn't, I knew not to talk about it. Essentially,
Sure.
it was taboo, especially in the 80s, right? And I did talk a lot about free energy because it all has to do with it,
Okay.
essentially. But that's kind of my legacy coming down from the man that actually saw the flying bell,
Well, maybe we
right?
can talk about some of that more exotic stuff in the next show.
Yeah,
Yeah.
you know what? It'd be awesome if we could get Carmen on with us because it was her father that actually saw
Okay.
it, and Carmen knows more about this stuff than pretty much any normal person does, other than you guys.
Sure, well, that'd be great. That would be neat.
Yeah, yeah. Well, we'll send this to Carmen and we'll ask her because I've asked her to come on. So yeah, for sure, she will at some point. Yeah, very cool.
Sounds
And so
good.
your YouTube channel is Stavatti Aerospace, is that correct?
I think so. Yeah, I should send you a link to that.
Yeah,
And
I'll put that in the description too.
yeah, it's
Yeah,
just has one video for the moment, but that's
Well, there'll be much more, I'm sure.
we're working on it. We do have other videos in the works, but you know,
Awesome.
so
cool.
there we go.
Um, yeah. Well, thanks again for all the knowledge and coming back on. And last time it was kind of difficult with you driving through the
Sure. Yeah.
snowstorm, and so much
Yeah.
appreciated.
No, I appreciate it too, and thank you so much, and look forward to the next video.
Yes,
Interview.
Sounds
thank
great.
you.
Okay.
And ciao for now, everyone.
Okay. Have a great night.
You too.
You too.